This video is going to serve as an extension of what we were doing in class with simplifying roots more than just square roots, and also simplifying powers and things like that. So I'm going to do a few of these from the 6.2 day 2, and then your responsibility will be to finish it as a group. So what we're going to look at, we've looked at now simplifying roots, like if I just had the cube root of 64 and so on and so forth. So we've looked at simplifying just numbers. So now let's look at also simplifying if there's variables underneath with it. So just like we were doing with the square roots and whatnot, we're going to write this into exponential form. So I've got 64y, sorry, 64 y to the 6th raised to the, and now since I have a cube root, it's going to be to the 1/3 power. So I'm going to give that 1/3 through to each of the pieces in the parentheses. So I've got 64 to the 1/3, so cube root of 64, and y to the 6 times 1/3, which gives me 6/3. So 64 to the 1/3 means the cube root of 64. The cube root of 64 in this case is 4. And y to the 6/3 is y squared, so this simplifies down to 4y squared. Okay, I'm going to jump down to letter B here. Okay, so I've got 7776. So I've got the 5th root of 7776. Maybe I'll just leave it like this, and then put the rest of it in exponent form. So I've got a to the 9th, b to the 12th, c to the 15th, and that's raised to the 1/5 power. Okay, so I need to simplify the 5th root of 7776, and then I need to simplify what I have in the parentheses. So it just so happens that 7776 is a perfect 5th root. Okay, so that if I look at using my chart, that's going to give me 6. And then I'm going to carry the 1/5 through to my exponents here. So I have a to the 9/5, b to the 12/5, and c to the 15/5. So how I'm going to simplify this is I'm going to pull out as many whole a's as I can, as many whole b's as I can, and as many whole c's as I can. Whatever's left will go back under the root. So in this case, I've got 6. So 5 goes into 9 one full time. So I've got a to the 1st, and I'm left with 4 a's. Okay. Now when I do b, 5 goes into b into 12 twice, and that leaves me with 2 left over, and 5 goes into 15 3 whole times with nothing left over. So now I'm going to take my whole numbers, so that's the a, the 6, the b squared, and the c cubed. That's going to stay on the outside, and the other two numbers, notice they have the same denominator for the fraction, so it's a 5th root, and that's going to leave me with a to the 4th and b squared underneath, and that would be fully simplified. So I have 6a b squared c cubed times the 5th root of a to the 4th b squared. Alright, so let's look at c. So it's already in exponent form, not in root form, so I'm going to carry the exponent through. So I've got 27 to the 1/3 power. P, 6 times 1/3 is 6/3, and Q, 12 times 1/3 is 12/3. So 27 to the 1/3 means cube root of 27, which is 3. P to the 6/3 gives me p squared, and q to the 12/3 gives me q to the 4th. Alright, let's change colors here just to keep everything separate. Alright, so now I've got the 4th root of a fraction, which means using my rules I can split that into the 4th root of m to the 4th over the 4th root of n to the 12th. And if I put that into exponent form, that's m. Okay, so the root is the denominator, the power is the numerator. So I have m to the 4 over 4 over n to the 12 over 4, so that's m to the first over n cubed. And I can't simplify these because they're not like bases. Okay, you're going to be doing E on your own. Just remember to use your rules. So when I'm dividing like bases, I can divide the 14 and the 2. When you have like bases, you subtract the exponents and see where you go from there. And don't forget negative exponents, wherever they are, you move them to the opposite part of the fraction. So if it's in the top, you move it to the bottom, and vice versa. So see what you get for that one with your group. Alright, so now let's look at continuing to simplify radicals. Okay, so you're going to do A on your own based on what we've done in class already. But I'm going to look at B because it's a little bit different. So I can't simplify this at all, so I'm going to leave that as 4 times the cube root of 4. But I need to look at the cube root of 600 and the cube root of 128. Alright, so if I do that, I'm going to split the 600 into the cube root of 8 times the cube root of 75. And then I've got the 3 times, and I'm going to split the 128 into the cube root of 64 times the cube root of 2. So this part doesn't change. That's still 4 times cube root of 4. Okay, now I've got the cube root of 8 is 2. So now I have 2 times the cube root of 75. And then I have the cube root of 64 is 4. So now I've got 4 times 3, so I'm going to multiply those. So I get 12 cube root of 2. Now the problem I have here is it looks like I can't do anything with this. Okay, so I'm going to put it back into exponent form because you're going to see what I'm going to do here. So I've got 4 times 4 to the 1/3 minus 2 times 75 to the 1/3. That's ugly. And then plus 12, 2 to the 1/3. So I'm going to use my exponent rules here really quick. Okay, so 4 to the 1/3, 4, I could rewrite that because I've got a base of 2 over here. I could rewrite 4 to the 1/3 as 2 squared to the 1/3. Now 75 cannot be written as a base of 2, so I'm just going to leave it as 2 times 75 to the 1/3. So now this 2 squared to the 1/3 becomes 2 to the 2/3. Okay, so I'm left with, again, I've got 4 times 2 squared to the 1/3. Sorry, I just ran out of room. Minus 6 times 75 to the 1/3 plus 2 times, 12 times 2 to the 1/3. So I'm going to rewrite this as 4 times 2 to the 2/3. And I'm going to move this over since they have like bases, plus 12 times 2 to the 1/3 minus 6 times 75 to the 1/3. So at this point, I see that I have 4 cube root of 2 squared plus 12 times cube root of 2 minus 6 cube root of 75. They look very similar. But the problem I have here is if this had stayed a 1, I'd be happy. Okay, I could have then combined these two, but because it's a 2 to the 2/3 and we're adding, I can't do anything with it. So at this point, this is as simple as it gets. But if we look at C, I'm actually going to be able to break this down so that I can combine some pieces because I'm going to make them look like they have the same base. So let's look at, which is square root of 7 plus the 4th root of 49 plus 3 times the 6th root of 343. Now these don't look like that they could be combined at all. So I'm going to convert this to power form. 49 to the 1/4 plus 3 times 343 to the 1/6. So let's see, since this one is not simplifiable, let's see if I can get one or both of these to have a base of 7. I've got 7 to the 1/2. 49 can be rewritten as 7 squared to the 1/4. And 343 can be rewritten as 7 to the 3rd. So now I've got 7 to the 1/2 plus 7 to the 2/2, which is to the first power. Oh, whoops, that should be a 4. 7 to the 2/4, excuse me. Plus, so that 1/4 came from there. So I've got 2 times 1/4 is 2/4 plus 3 times 7 to the 3rd, so 3 times the 1/6 gives me 7 to the 3/6. So if I can simplify those fractions, I've got 7 to the 1/2 plus 7 to the 1/2 plus 3 times 7 to the 1/2. So now, unlike the one before, I couldn't combine it because we had, say, 2/3 and a 1/3. Because these are all to the 1/2, I've got 1 square root of 7, 2 square roots of 7 plus another 3. So that gives me 3, and then 7 to the 1/2 is square root of 7. Or 5 square root of 7. I'm sorry, I can't add apparently. 1, 2, one of these, another one of these, plus 3 gives me 5 square roots of 7.